Imagine every undergraduate student at UC Irvine flips a coin 10 times. Do you think there exists a student who is going to get heads all 10 of those times? So what I want to show you in this video is how we can use Mathematica to investigate that question. And the main thing we have to come up with is how do we simulate these different things I talked about? How do we simulate flipping a coin? Or how do we simulate flipping a coin 10 times? So let me start with the flipping a coin. Let me say flip. And then here's a new function we haven't talked about, random choice. This takes as input a list. And so my list, it's just going to have two items in it, two strings in it. So strings in Mathematica are inside of double quotation marks. One string is going to be heads, one string is going to be tails. And so now flip is this random choice. And what if I want to flip a coin 10 times? That's really easy. So let's call it, how about 10 times? And remember, we're not allowed to use an underscore. So like 10 times, like I might have named it in MATLAB. That doesn't work in Mathematica. So I'll use 10 times. And then this is going to be table. I want to flip, and I want to flip it 10 times. So this seems strange, and what went wrong? What went wrong was I didn't use the delayed assignment. So flip, I'm going to use delayed assignment for that. And 10 times I also want to use delayed assignment for that so that I can do it once for each undergraduate student. Okay, so let's look at it just one time. So here, already that's kind of strange that it started out with 7 heads, but then tails, heads, tails. And if I evaluate it again, it's going to look different. So it's just some random set of 10 heads or tails outcomes. So what do I want to do now? I want to simulate flipping this coin 10 times. I want to simulate it once for each undergraduate at UC Irvine. So how can I do that? Well, let me make a new table. And I want to have one of these 10 times. And I want to have it for each student at UC Irvine. So like if there are 500 students, I could do it like that. That would say run this experiment, this 10 flips experiment, 500 times. So total what I have here, that would include 5,000, 500 times 10. It would include 5,000 total coin flips. But 500, that's not the population of UC Irvine. So let me show you a cool way in Mathematica to get that population. I'm going to write pop for population equals, and now what you should expect is a number that's equal to the population of undergraduates at UC Irvine. And we're not going to work with this too deeply, but I want you to see that it exists. I can actually connect to the internet by holding down Control and then hitting the equal sign. So this is like an interface with Wolfram Alpha, which you've probably heard of before. So when I held down Control and hit the equal sign, that gave me this little orange box around an equal symbol. And then let me write undergraduates at UC Irvine. And then I'm going to evaluate it. So that's pretty cool. This POP variable that I just defined, that's defined to be 24,489, and the unit is people, but that's not going to have any influence on us. So instead of having this 500, I'm just going to write in pop here. And let me call this total outcome. So what is that? That's a list of lists, and each item in the list looks like one of these outcomes. So just as an example, say I do length of this total outcome. So that's what I was expecting. And if I were to do length of total outcome square brackets 5532, that's 10. Why is it 10? Because that 5,532nd entry, that was one of these. Okay, so if I were just to look at this total outcome, 5532, okay, this is what it looks like, some list of length 10. And you might notice that here I defined it with immediate assignment instead of delayed assignment, and that's because this total experiment that I want to do, I want to just do it one time, and then I want to ask various questions about it, and I want to have the same result for each of those questions that I ask. So that's why I used an equals instead of a colon equals. So next thing I want to know is for each of my 24,489 experiments, how many times did heads show up? And my overall question was, does there exist a student who got heads all 10 times? So let me make a new table. So let me just call it new table. And that's going to be table. And I want to go through each outcome in my total outcome. Okay, so this X, it's going to go through each of these length 10 lists, all 24,000 of them. And then what do I want to do for each of those lists? I want to count for that X, how many times did heads show up? And let me not put a semicolon at the end of it so we can see what it looks like. So this is like saying the first student got heads 6 times, second student got heads 6 times, the fourth student got heads 5 times. So let's just check that and see if it looks right. Let's look at total outcome. Let's look at the fourth student. And so if I were to count heads in this, I'm supposed to see 5 of them. 1, 2, 3, 4, 5. So that's what this 5 here stands for. So there's my new table. Let me hide it by double-clicking over here on the end bracket. And what do I care about? I care about, is there a student who got heads 10 times? So that's like saying, inside of new table, do I see the number 10? Hey, is there a student who got heads 10 times? Yep, not only is there one student, but for this specific experiment, there are 27 students. And one way to think about it is, what's the probability that a single student got heads 10 times? Well, it's 1/2 times 1/2 times 1/2 for 10 total times. So it's like 1/2 to the 10th. So it's like 1/1024. So if I have 25,000 or 24,000 students doing something where there's a probability of 1 in 1,000 of it happening, then yeah, it makes sense that maybe 27 of them are going to have that occur. So maybe 27 of them, okay, not exactly, but for this specific experiment, maybe 27 of them got heads all 10 times.